say, large amounts of climate, weather, and observation data. So we want to understand how we can kind of study, let's say, data from the observation from the past and trying to capture the patterns of this by using data-driven models.
Ratanlo is here with me today. So introduce yourself, and then we go through your experience in interTwin.
Okay, so hi, so my name is Donatello Lee. I'm from the CMC Foundation. I'm a computer scientist at the Advanced Digital Innovation Center. And in particular, I'm leading two of the use cases in the interTwin project concerning extreme weather events, in particular related to wildfires and tropical cyclones.
So yeah, I suppose we will also have some other extreme weather use cases maybe later on. But what's your main problems where we talk about solution and machine learning based solution for this kind of problems?
Okay, so the idea is that we now have, let's say, large amounts of climate, weather, and observation data. So we want to understand how we can kind of study, let's say, data from the observation from the past and trying to capture the patterns of this by using data-driven models, and then basically try to use these models in place of traditional methods as fast computing solutions, like for handling this extreme event on climate. On future climate data. And we need to tackle, let's say, although these solutions are quite promising, we need to tackle different challenges, which, for example, are linked to the complexity of these workflows, which can be quite time-consuming, as well as the fact that these need like HPC infrastructures, so they might need to be important.
Yeah. So just to understand, there are and there were already solutions for that before interTwin, right? So
yes,
the project itself aimed to enhance this experience, to bring up everything together with other use cases from the infrastructure part and also from the tooling part, right?
Yes, there are already, let's say, traditional approach. We can consist of deterministic methods or numerical methods. With machine learning, there's they have kind of the potential of trying to detect patterns from the data, as well as providing a solution which are, let's say, faster. So that's the main goal. But of course, this also carry some challenges which might need to be addressed, and the interTwin project is providing the tools and the components to tackle this challenge and simplify the implementation of the digital twins, basically.
Cool. So yeah, I'm curious. What's your experience, and what is? Yeah, we know already, and we repeat in every podcast that we are closing this project, so we are very close to the end. What's your experience? What's the highlights on the outcome that you get from this?
Yeah, I think that one of the nice things from the project, from my point of view, is that basically allowed us, thanks to the digital twin engine and the components which are provided by this digital twin engine, from some part to understand which is a way to support this implementation and thus make it simpler. But also some best practices while implementing these components. So, for example, the use of containers allowed to make the digital twins more portable. So we were able to test the implementation very easily on a multiple infrastructure, both cloud and HPC, by just moving the container.
Yeah.
So that's one added value.
It's a bi-directional exchange, right?
Yes,
so
yes.
that the scientists need to adapt in some way, and then from the platform itself, there should be compromises of sort, right?
And that's one, but there are also other additional things. For example, the use of components for handling the AI workflow allowed us, for example, to track what was going on during the training, which is very useful for documenting the process and then go backwards and check what we have done and see how the model were for example, performing, which one was, let's say, the best one. So it's supported us in the implementation and the development stage of the machine learning models for these applications.
And out of curiosity, are these models usually shared between a group of people, or are single people developing and then sharing? How is the development?
Yeah, in particular in the project we were working like with a team, so there were multiple people working on the different use cases. So using this tool allowed us somehow to also look more easily at what were the results of the training stage. In particular, maybe when we have, let's say, users. For example, we have maybe like developers and others that are not I just maybe want to understand how it's going on, which is like the best model to be used. So by using, for example, the ML flows set up within the project through the interTwin AI software, we were able to track easily the training metrics, so we can go basically and check them later by even like going there like through like checking them as a team, and so we could like check together how they were going and which one was, let's say, the one that we could select as a good one.
Nice. So, and this, I suppose, you get it by, how would you say, by working at the cloud level. So there are all frameworks that talk container, at least, even if not cloud themselves. What about the part of the work that takes a lot of computing power? So do you have use cases for scaling to the providers of interTwin? This was something that facilitate your work, or?
Yeah, in our case, we were running the training on multiple GPUs. I think we tested this with 4 GPUs on testbed, which was running on the Vega infrastructure. Of course, running distributed GPUs allow to speed up the training. So it takes, say, a few hours. So of course, having multiple GPUs makes it faster. But the nice thing of using the containers was that we could use the same environment created once, both on a more, let's say, HPC infrastructure, but also on a cloud infrastructure, where, for example, we will maybe run smaller trainings or maybe just focus on the inference part.
All right, nice. So you have, I'm sure, some practical example, right? Of course, we have no time to go through all of them exactly, but for people outside this last use case where you have multiple GPUs, you want to do a training, what are the steps that you usually take for getting to the end? So I need to prepare data somewhere, I need to think something else, this kind of stuff.
Yeah, so there are, let's say, the workflow for a training machine learning model, let's say, has multiple steps from the selection of data, the preprocessing of the data, running the model for multiple epochs, and then at the end, running also the validation stage. In the context of interTwin, we actually implemented all the different steps as part of the thematic modules, which are used for the digital twin applications. So we try to make the implementation as easy as possible for a user. And at the end, there are just let's say, 2 main steps that need to be implemented with this approach. So first is like having the data ready. In that case, we are relying on the interTwin data lake to have the data available on different sites. And then from the model, we can just select the configuration arguments for the training that we want to run, and through a simple script, we can run this on the GPU. And once it's done, the model will be automatically uploaded on the MLflow instance.
Yeah, and I suppose all these steps are public somewhere.
Yeah, they're all part of the workflow, the thematic module, which are on
Yeah,
GitHub.
so we will share the link below after the recording, and yeah, you can get an idea of how easy or not is to this kind of stuff. Yeah, so there is a question that I'm doing to everyone. Also, you are no exception, as I mentioned before, to others. What's your impressions? How was your journey in interTwin? So, the difficulties, if any, or any kind of things that you appreciate for people, and from the technical perspective, that's, yeah.
Okay, there were, of course, let's say, several challenges, especially at the beginning of the project. But while things were moving on and pieces were starting to come together, the infrastructure was actually, especially in the last part of the project, quite useful. So with the Jupyter Hub instance set up, it was quite easy to get access, for example, to the container that we created, and also running the training wasn't very difficult. As I mentioned, we could like move this part on different infrastructures. And yes, and also, the people in the projects they were, I say, very collaborative. So it was actually quite a nice experience, I would say.
Yeah, nice choice because it's recorded, so they will discover anyhow. No, joking apart, I agree with you. So I think we are coming to the end. That was all the time we have at disposal. Unfortunately, I like also maybe to share some link if there are live demo or any other video for practical things. Yeah, so thank you for your time.
Thank you.
And see you in the next episode. And yeah, thank you all. Bye bye.
Bye.